Lots to read here. The concentration of dilute sulfuric acid can be determined by titration with sodium hydroxide solution of a known concentration. 25 centimeter cubes of dilute sulfuric acid was measured out using a pipette and transferred to a conical flask. A few drops of methyl orange indicator were added. This is a single indicator, it will change one colour. And that's what you want for titrations, like phenolphthalein and methyl orange, not universal indicator. It has to change into one colour so you can be precise when you've neutralised the substance. Were added to the acid in the conical flask. Sodium hydroxide solution was added to the acid from a burette until the indicator changed colour. So you've got your setup here, you've got your sodium hydroxide here and your acid here with your single indicator, your methyl orange, and what you're doing is you are dropping drop by drop sodium hydroxide through here from a burette so you can measure the volume, and you're swirling and swirling and swirling to evenly distribute it, and eventually there'll come a point where one final drop completely neutralizes this, and you'll get an instant color change of methyl orange. The titration was repeated until 2 concordant results were obtained. So 2 of the same results were obtained. In other words, you got 2 of the same amount of volume that neutralized it. The accurate result was the average of the 2 concordant results. So it takes a while, maybe a bit of practice to get this working correctly. So you basically keep going until you kind of set this up correctly and you had enough practice to get it right. So 2 concordant results were averaged. The first question is really easy though. Describe the colour change seen at the end point of the titration. For this, you just need to understand methyl orange. So methyl orange was added to the acid. So in an acid, it's red, but when it becomes neutral or alkaline, it turns yellow. So you just have to say from red to yellow. Or yeah, that's that. Next, it could ask you for phenolphthalein, where you'd have to think about pink and colours. A brief report of the practical method has been given above. Further detail can be added to this method to ensure that anyone following the method will obtain accurate results. Explain 2 details that can be added to this practical method to ensure an accurate result is obtained. So explain means say what you're going to do and give a reason for it twice. And this one's for 4 marks. So there's a few things. Notice, as I say, the sodium hydroxide solution was added to the acid from a burette until the indicator changed colour. Now, I went into more detail. I think you need to add a bit, and then towards the end point, you let it drip by drip so you know the exact last drop that caused the neutralisation. So the first thing I'd say is add alkali 1 drop at a time near the end point, or just 1 drop at a time, to identify exactly when the indicator changed colour. Then you'll get an accurate reading of the volume. The next, they're just dripping in, and I talked about this idea of swirling and mixing it, and that's really important. So continually swirl flask to ensure acid completely mixes with the alkali. In the titration, 25 centimeter cubes of dilute sulfuric acid reacted with 24.25 centimeter cubed of 0.2 mole dm cubed of sodium hydroxide solution, NaOH. Here's the equation. It says, calculate the concentration of the dilute sulfuric acid, H2SO4, in moles dm cubed. Now, the first thing it says is it wants you to calculate the concentration. And to work out concentration, you need number of moles divided by volume. Whenever you have to do titration calculations, the easiest way to do this is to make a table, and then suddenly things start to fall into place. Otherwise, these kind of questions can be overwhelming. So put your acid and your base, and you want your 3 factors involved in this equation: volume, moles, and concentration. Now, I've highlighted this one because that's the one we want to find out the answer to. I've input the numbers we know, so 25 of acid reacted with 24.25 of base, and we know the concentration of that base. What we don't know are the moles. We need that, and obviously we need to know the concentration. So we can rearrange this equation to work out the number of moles. Volume times concentration equals moles. So you can see by multiplying 24.25 by 0.20 will give you the number of moles, which is 4.85. Now, you may notice actually that here it's in decimeter cubed, and they're giving the volume in centimeter cubed, and you should really make this decimeter cube. You should divide these values by 1,000 to make them decimeter cubed, but actually I'm not in this example just because you end up with the same answer anyway, but it's good practice to do the unit for conversion. So I would do that in future, but I'm sticking with these just because it's easier to write in this small table and you'll get the same answer. So we know that 4.85 is the number of moles. Now, how do you work out the number of moles here? Because you haven't got another value here. But actually, if you look at the equation, this is the base, this is the acid. You know that 2 moles of, in this reaction, 2 moles of base reacts with 1 mole of acid. So this is 2 moles, so 1 mole will be half that, which is 2.425. So finally, we can now work out concentration. So concentration, as we know, is number of moles divided by volume. So if we divide this value by this value, we get 0.097 moles per decimeter cubed. So as long as you have this table and this formula, you can work it out much easier than it first seemed. Finally, the concentration of some dilute sulfuric acid, H2SO4, is 0.25 moles per decimeter cubed. Calculate the concentration of sulfuric acid in this solution in grams. So what we've been given here, without maybe realizing it, is the number of moles in 1 decimeter cubed, the number of moles, and we've been given the atomic mass, or rather the formula mass. So what equation links grams, moles and formula mass? Well, it's the only equation you really use to do with moles, which is mass divided by formula mass equals number of moles. So all you're doing is rearranging that because we're trying to find out what mass is, so you can rearrange that to number of moles times MR times formula mass equals mass. And if you do that, you have 0.250 times 98, which will give you 24.5 grams, 2 marks.